Any questions you have for us, like while all of this is booting up, like the?
Please tell us.
Yeah. Shoot.
This was actually my objective, or not my objective. This was the thing I wrote in the Google Forms. But any quiz advice, or for like the level 2 quiz or the calculator quiz, like anything.
So the calculator quiz is this Friday, right?
Got this.
Yeah.
Got this. You ready? Get the questions correct.
Whoa, wow.
Snap. Okay. I mean, actual answer for that question, essentially, a big thing to be looking at is read the documentation. Like, even if you don't get the points on calculator or anywhere near it, like, to do well on the homework quiz, like, that's this Friday, read the documentation that Jesse gave you on basically what the calculator is supposed to do and what he doesn't care if it does, and read through everything that it's supposed to do so that you have it memorized. I should be able to tell you, like, what does 2 plus times 3 equal show on the display. What does it show?
Wait, 2 plus times 3, 6. Right?
2 plus times 3 equals, what's in the display?
6.
6.
I said 6, didn't I?
Yeah.
Oh.
But basically, yeah, it's, you want to know exactly what every scenario should, like, how the calculator should respond to every single, like, input scenario. Like, that's gonna be a big thing.
Alright, actually, I also have another question.
Yeah.
Or not. But, so, what's that? Anyway, I don't know if this is functionality we need to implement, but I don't have a 4-function calculator, and a friend gave one to me recently.
Your phone calculator work.
Well,
Everything you do on your phone calculator is what this mimics.
okay, because anyway, on the 4-function, if I put like 4 times equals, it will answer 16, and it just assumes the second operator is the first one. Is that something that
No. Everything that he wants a calculator to do is in that documentation.
Yeah.
Anything not specifically said in that documentation, he doesn't test for, he doesn't care about, don't try to do it.
So again, if I type in 4 times equals on my phone, it doesn't do anything. Base it off your phone calculator, don't base it off a 4-function.
The Android calculator is actually pretty accurate to what
He wants.
he wants to actually function. I think the iPhone calculator is pretty similar in its functions. The best representation, I'd say, of what the calculator should be doing is the Windows calculator, because the Windows calculator is one of the most generic calculators existent on the planet.
That too.
And it even screws up in certain areas if you know how to screw it up.
Yeah.
Alright, thank you.
Oh, I really gotta take this other thing away.
So it does do that. No, it does the same as with the 4-function calculator I was talking about. Do you do 4 times equals? So 4 times equals, it puts 16, hit again, 64.
Yeah, if you remember reading at the very bottom of Objective 3, there's a bullet point that says note. In there it says, if you press an operator and then the equals sign, that is an undefined action because of these notes, and so don't worry about it.
Yes.
All right.
Okay, let's look to see what you guys want us to...
Start here. Everything blows.
Okay. So...
We'll switch over.
I know.
Did you guys all put in your tiny URL for
It's
the
this.
review attendance?
Some of it's that. Some of it's the thing here. Because I
Yeah.
forgot I had another option that you can actually write things in.
Yeah. Okay, so what I'm seeing... Okay, so here...
Let's just start with states and then go after.
Yeah, let's talk about states
All right,
and then...
you talk, I'll type.
Yeah. So we'll talk about states.
Also, you stand over there.
Yeah, I'll stand over there.
All right.
So yeah, we're gonna talk about states first. Talk about kind of like some of the homework. Did Jesse get back to on what I'm kosher to say
For what?
about calculator?
Yeah. He said. I think he said that the thing that you put in the Slack was good.
Okay, let me just double check that. I want to make sure that I like don't tell you guys too much information, but like what I can tell you is like, allowed. Okay, awesome. He literally said, do whatever you feel will help them the most. So, you guys who are here, you get an advantage. And anyone who's on the stream, you guys are also going to be able to hear some of this stuff. Okay, so we're going to talk about states. So, that's a Java file.
Nah, oh, yeah, that one is a Java file, might be.
Let's not scare them with Java. We're not doing
I
Java.
love Java.
No, you don't. Java sucks.
Java's fine. We can agree to disagree on that. Java's fine.
It's not good.
JavaScript sucks. Anyone who tells you they like JavaScript, they're lying.
No, that's
And if
different from Java though.
huh?
That's different from Java.
Yeah. But anyone who likes JavaScript, they're either lying or they're like masochistic. Like, do not trust that person if they say they like JavaScript.
Or C++.
is great.
C++. Some people like it, some people don't. Everyone like genuinely like agrees on that JavaScript is stupid.
Yep. Okay.
So yeah,
this is my example.
Oh yeah, I can work with that.
I figured you probably could.
Yeah. So let's start out. Let's make that an abstract
No,
class.
this is the.
Oh, that's.
Yeah.
Oh, okay.
This
So that's a
is,
state. Computers. Gotcha. Okay. So I understand. So.
Wait, actually, hold on. You start talking. I'm gonna make this bigger.
Yeah. Thank you for that. Like presentation mode. It's under view. Under view is presentation mode at the bottom.
Wait, that's a thing.
Yep. Once it opens up, it'll be full screen and much larger.
What?
Yeah.
But how do I change?
I don't know that one.
Oh. It's not one. There we go. Okay.
Awesome. Okay. So, yeah, we're going to start with this, and we're going to kind of have it in the similar structure to how Calculator is set up, and so how you should kind of be thinking about this. So, let's define, so computer user is going to be essentially like what our calculator is, and it's going to have a state in it. So that state, let's say initially when you have your computer, it has 3 different operating systems on it that you can switch between. We have PC, Mac, and Linux. I don't think we have Linux on there. So let's just say PC and Mac at the moment.
Can make more things.
Yeah, he can make it more, like while I talk. He can type faster than I can talk. I'm not great at talking. English is not my strong suit. That's why I'm in comp sci. But essentially, yeah, we're in this computer user. This computer user has a state of whatever operating system you're currently in. If you initially boot up this computer, it's going to be initially just set to PC. So that's like if you open up your BIOS and you have something that's dual booted, and initially if you just let it wait the 5 seconds, it's going to just boot into PC unless if you give it some commands to do other shit. So what we need to look at and what we need to keep track of is we're going to create some functions that simulate buttons on the PC. So let's say we have a button on the PC that is power on. We have a button on the PC that's power off. Those are all methods that are inside of our state. We're going to have, and then we're going to have 3 different methods which are going to be switching to whatever operating system we want. Like, let's say we're going to have methods that essentially it's going to say, okay, we want to switch to the PC partition. We want to switch to the Mac partition. We want to switch to the Linux partition. And so we have all these functions that we can call and switch to whatever state we want to. Is everyone starting to follow kind of what Logan's typing while I'm talking? Like we're all on the same page? I see a few glazed eyes. I just want to make sure that if there's anything more I can explain while he's typing, I can. Okay. So what we're going to do, we're going to have open text editor.
Yeah.
So
like specific ones with specific things inside of them.
Yeah.
It's like Vim Pages Word.
Like VS Code for with
yeah,
that, like
yeah,
okay.
yeah.
Yeah, so then we're going to also have a specific function that's going to be, we're going to have a few specific functions that are going to be different based on the operating system you're in. Like we're going to have the open text editor and open browser. I'm going to actually move this so that I can see it from where while you're talking.
Oh, yeah, that could be a cool idea.
See, go up.
I know, it wasn't going up for me either.
Whatever. I don't care. It's fine. So yeah, we're going to have a few functions that are a little bit specific for the state, so that open text editor and open browser, like, so we know that, like, okay, if we're in the Linux partition and we open up our text editor, it's going to open up Emacs. Ethan Blanton loves this editor. If you ever have a class with him, he will have multiple lectures that are just him preaching about Emacs. He loves it. I kind of like it. I don't like, I'm not at the point yet where I want to preach about Emacs, but he'll preach about Emacs.
Right,
and
but it's more of a, in Linux it'll open up Vim or Emacs or whatever, and on a Mac it'll open up Pages, and in Windows it'll open up Microsoft Word. So like a specific one to each operating system. Browser, it'll do the same thing. So on Windows it'll open up Internet Explorer, on Mac it'll open up Safari, and on Linux it'll open up Firefox, I think is the default one at this point. But regardless, it'll open up something different on each operating system. Yeah. So it has to check the states.
Yeah. So essentially what we'll be able to do is we'll be able to call functions, and based on what it returns, we'll know kind of what state we're in, and we won't necessarily need to do like if statements to say, if we're in this state, return Firefox for the browser. If we're in Linux, like, we don't need to do those if statements because this has already been predetermined on how states are going to be set up while he writes this. And so essentially how we're going to now do this is we're going to hop back into the computer user, and we created this initial state. And so this initial state is PC, and
this is going to yell at us for a little bit. Don't worry about it.
Yeah, we haven't set it up yet.
We haven't made PC.
And so we're going to have some functions inside of computer user that we're going to just, rather than actually creating like some action handlers and that stuff, we're not working with a GUI in this specific one because we are not going to write a GUI from scratch for this review session. That is a lot of work. So we're just going to pretend like we have specific methods that will be called by your controller. And so Logan will create those methods while he writes them. They shouldn't be in parentheses. It should be in curly braces.
Yeah, I know how to code.
Yeah.
That's a good joke, actually.
Yep. Okay. So we're doing great right now.
It's gonna yell at me.
You should put an equal sign after the unit.
Yeah, I know, man. It's been a day. It's been a day.
We know how to code. We swear. Please promise you believe us. Like, nod your head if you believe us. I don't see enough nodding. I guess you're all failing. Okay, so yeah, basically we're going to create some of these method calls, and what it's going to do is we are essentially just creating all these method calls so that we know if like a button gets hit, like a specific thing happens. We don't need to know which partition we're in. It will just return based on whatever operating system we're in, because the operating system knows what to do, and we don't necessarily care which one. We just care that it does what we want it to do. So what you see him making here right now is he's doing these state calls. So what we know is that inside of this state that has the type of state, that type of state does not need to be the name state. It needs to be whatever you create that class file. That's the abstract class. You can see it on the left hand side of the screen. It could be operating system. It could be like partition. As long as that, like, whatever you name that abstract class, that's the type of it. And also, here's a little pointer with Scala and IntelliJ. It gets a little picky if the file name and the class name that's in that file are different, so don't have them name different things.
If I just change it to user, it's gonna
get mad, and it's gonna say change computer user to user or change user to computer user.
Yeah.
Like, it wants one of them changed to the other. It doesn't care which you do. You get to choose which, but they got to be the same. So basically what we have here is we have a few calls. So now we're going to go into PC. So PC, we're going to implement the initial on. We need to extend that abstract class. And so this is where we start getting into states. This is where we start understanding states is going to take a parameter.
Oh yeah, you're right.
And so states is going to take the parameter that is the user.
Yeah, I don't think I made it take a parameter before.
Yeah, so states takes the user, which is the actual computer user themselves. That is going to get extended onto PC. If you do Alt-Enter on the red that is PC, what happens is if you are extending an abstract class and do Alt-Enter, as Logan is going to demonstrate,
it's implement methods.
yeah, you do implement methods, and what it does is it takes every method that you need to implement and tosses it in there. So you know exactly what you need to remember to implement. This is very helpful. I love using IntelliJ's Alt-Enter for this stuff because I forget at times. It is the one redeeming quality of IntelliJ.
It's not true. There's others.
Agree
to disagree.
Okay. Yeah, question.
Okay, so for your state class,
Yeah.
thing the constructor, is that what kind of value is that?
So that's a constructor. It is specifically of type computer user. The point of that is we are passing computer user in so that if you hop back into computer user, Logan, when we create it, we initialize it with this. That allows us that if we have, like right now inside of computer user, there is a variable called state. That variable is var. That means that we can change state around. But what it also means is because we're passing computer user into PC, if PC needs to transition from PC to Linux, that variable that actually tells the computer, it's like the actual compiler, which state is what, that state variable is stored within the stack frame of computer user. And so by passing in computer user into PC, that allows us to edit that variable by knowing where that memory address is. By passing that variable, we know that the memory address for computer user.state is at 1234. That means that if we're inside a PC, we can say this memory address is now going to point to new Linux user or new Mac, like whatever we need to do so that essentially we can swap around that state variable. What will happen is if you hop back into PC, so let's implement the toLinux method. And so if we implement the toLinux method, yeah. So let's actually toss one more method into the state. So what we have here is let's add one more method. Actually, so we have a method called def processor running. Processes running.
I don't think this is doing what you think it is.
Okay, then let's create a separate method in the abstract class. Let's create it and call it the hello operating system method. This is the method that just says when you boot up the computer or switch into that partition, this method gets called and just prints to your screen, hello, I'm in blank operating system. And so what it is that you can just see this transition that happens so you know what operating system you're now in. And so essentially, we know that hello OS is going to print ln, hello, you're in PC. The hello OS for Linux, we know would say, want to hop into Linux and we'll do the implement on that and just implement what we need to. So in Linux, its hello OS is going to print hello, you're in Linux. What's going to happen is once Logan gets this all set up and those methods implemented, that is a method that is inside of Linux that can be called. Now, the trick that I'm going to show you is even after you switch what the state is. So when we have, yeah, you don't want abstract class.
Yeah,
you want
I pressed the wrong button. You know what? Okay.
Yeah, okay. So if we throw the print statement into hello OS and then we hop back into PC, what's going to happen is, yeah, Awesome. So if we hop back into PC, what we know is that if you put a line right after that state change, so right after 13, what happens is we can do user.state.helloOS. What this means is even though we switch the state, so this PC class that we're in right now still exists in its own stack frame. It still has all of its variables it still has access to all of its methods. But this class is no longer tied to the user.state because we said user.state is equal to new Linux user. So what happens is by saying user.state.helloOS, what is it going to print?
Well, oops.
Oh, yeah.
It's going to print that.
Yeah, it's supposed to print that. So essentially what's going to happen is it's going to say this is Linux. What this means is that if you transition from one state to another, you still have up and through the end of that method call. So until you hit that final brace of the to Linux brace, so the line 15, up until you hit that brace, this class is going to exist. As soon as you hit the end of that brace, that method is gone. That entire stack frame for PC disappears, or that heap frame will disappear, and we're going to hop back into computer user. So what's going to happen is that means that when we called that and created that new PC and we click to Linux, now we know that that state up top at 2 is now going to be essentially equal to Linux, which means that any call now that we do, it will be in the Linux class. So if we hop into the Linux class, we could call hello OS and it's going to return like hello, this is Linux again. If we did open browser, then what's going to happen is it's going to return Mozilla Fox or Firefox. Mozilla Firefox, yeah. And so this is where we start thinking about state transitions, and the reason why I mentioned that you can put that extra line is in Calculator, if you are in an operator state and you're trying to transition into a digit state, and what you have is essentially you keep all of your numbers inside of number state, and you have a number input, but you're in the operator state, operator isn't necessarily going to take that number and do whatever you need to do to make it display, but it can take that number, set your state to a number state, and then it can take that number state and do the normal call that you would do if you were already in the number state. And so essentially, like, what that allows you to do is look at all of that stuff and figure out, okay, if I need to pass something from one state to another state, that transition method call, if we hop back into PC, that transition method call, that's where we have the ability to take a variable. Like, if to Linux actually took a variable in, we could take that in, and then after the state has changed, we can do user.state whatever method we need to call with that variable. That's how we can pass variables from state to state without necessarily having to save them inside of computer user and then recall them from computer user and then call the method again on this other initialization call. Is everyone following so far? Yeah.
So you're saying you shouldn't have to, like, you should be able to do it that way in the calculator, and like no matter what we're doing, we should be able to do it like that?
So specifically, I actually tested that what happens is I looked at all of Jesse's lecture slides on how he taught states to you guys. I looked and re-looked at his like Dr. Banner and his lecture slides, like with his transitions from like Bruce Banner to Hulk and all of those transitions in between. I looked at how he was trying to explain states, and then what I did was I actually looked at my calculator assignment from last semester and then went, this is garbage. deleted the entire thing and then rewrote calculator to follow how the lecture slides were so that I could basically figure out exactly how do I explain this to you guys so that yes, the short answer is yes. You can do it with these transitions. You can do it with keeping track of these variables on method calls so that essentially you have your calculator structured very similarly to how Jesse is doing transitions. And so if we're looking at calculator, right now we have computer user, and let's hop back into computer user. How many states are there for the, let me word it better. For the variable that is the lowercase state, how many different states can it be in? 3. It can be in Linux, Mac, PC. So that's 3 different states that it can be in. Now, let's think about calculator. In a calculator, if we were to generally group calculator in its buttons, how many states does that have?
Oh, wait, no, hold on.
4. So what are the 4? Shoot.
Number, decimal, operation, and equals.
So close. If I were to actually group them into 4 different types of buttons, I would actually group decimal with the numbers, because decimal is never going to be pressed outside of typing a number, and it is only going, you're not going to do times, and then if you hit a dot, if you do 1 times and then you hit the decimal point, what are you now doing? 0 point something. So you're now typing a number. So what I'd say is the actual 4 different possibilities of types of buttons are clear, an operator, an equal, and a number typing button.
Now, if you want, it could be more than that. You could have clear, equal, number, addition, subtraction, multiplication, division, which is I think I did.
Yeah, no, I did it. So it worked with transitions. It's a little bit difficult to keep track of some of the stuff with that. Yeah. So what you need to think of is essentially if we look at left-hand side. So I'm going to actually. Is there a way that I can write on your computer, on a sketch pad?
Yeah.
Okay. I want to kind of draw it out, but essentially what I want to try to talk about is essentially when we have left-hand side, right-hand side, operators and that type of thing, I want you guys to just kind of verbalize what is going where. Yeah.
Because in mine, I was thinking that left-hand side and right-hand side could be their own states as well.
That's what.
So where I would say with that is if you have the difference between a state, where you should have a state variable and where, you have a touchscreen, right?
No.
Oh, you don't have a touchscreen. Oh, wonderful.
Over this, yeah.
Where's your mouse?
It's there. It's just because.
Oh, I see.
This is my.
So essentially, what the difference I'd say between when you should use a state variable versus when you should use an actual state, where you should use an abstract class that extends a bunch of stuff, or a class that extends an abstract class, is where you're using it. If you're using something and it is a pure and only value, left-hand side and right-hand side are 0.0. They're just values that you are going to play with. You're going to have a variable that may be what you're displaying, what you want currently displayed. You need to keep track of all this stuff, but essentially those are all just variables. They're individual variables. You don't need to do specific function. Functions will take them in, functions will edit them, but there's no function that is LHS or RHS specific. It's just where there may be a situation is whether you want to add into the RHS or you want to add into the LHS, but you don't need to necessarily do that. what you can think of is where we're going to kind of talk about this is, let's say you have a block here, and this is going to be your RHS, or not RHS, my left versus my right. This is going to be your LHS. And I'm doing this on the computer and positively hating myself using Microsoft Paint because I want the people on the stream to be able to see this. So people on the stream, please watch this. You'll make me feel better about myself. It's not easy. Okay, so we're going to draw these wonderful brackets, which are positively disgusting. And we're going to do RHS here. And so, and then let's say that this is what we are currently typing. This is our input.
I have a better way to do this next time.
Yeah, well, I don't want your better way. Okay, so basically, let's see if we can just switch the text so that I can actually just type. Okay, so if we type let's switch this up to about 20. So we have an input. What happens if we hit the 1 on the calculator? The input is 1. Awesome. Let's actually switch that up to an even larger size. We're going to just make this colossal. That's not even colossal yet. Okay, so 48. That's just
Full send, 72.
No, 72 is too much. Okay, so if we hit 1, we have 1 in the input. Now, do we necessarily, think about in the calculator. If we know that we've started the calculator, we don't necessarily have an idea whether, the calculator doesn't know if it's just started or not. It's all dependent on states and where everything is. And so what you can look at is essentially think about the flow. What does the calculator have to see? How do you lead it to do exactly what you want it to do? So what you need to look at is you have an input, and then let's say you type 2. You have 12. Now let's say you type decimal and then 5. So you have 12.5.
Wait, hold on. Before you go that far. What should not happen when you press 2? If I press 1, right? And then I press 2, what should not happen?
The 1 should not go away.
Yeah, it should not overwrite. Like one should not be like forward.
What else should it not do? It shouldn't turn into that,
Yeah.
right? You shouldn't start adding them then, right?
Oh.
Do we all get that?
Yeah.
Oh, yeah.
Okay?
Oh.
So it should be 1, 2, not 3.
Yeah.
Got it? Good.
So you have 1, 2, and you hit a decimal place, and then let's say we now have 12.5. And so what happens when we hit plus? Where is that 12.5 going to go? Into the left-hand side. Now, if you think mathematically, does the computer know if something is in the left-hand side or not in the left-hand side?
No.
It has no clue. You need to determine that with states on how this is going to move. So let's say you started your state, and let's say what actually happened was you had, your calculator doesn't know this. You may have it already started with a state where right-hand side or left-hand side is 1, and the operator is plus, and you just put 12.5 in the input. If you started your calculator that way, does it know any different? Does it have any clue about that? And so what actually happens is you're essentially taking this 12.5. I wish that I could just
Touch the screen.
Oh no, also like be able to like just, okay, see if I can do that. And so it takes the input and it actually puts it in, okay, why are you just stupid? Okay.
Drag it before, man.
Okay, well I had to create other stuff. And so it actually looks at it in the right hand side. And then what you need to do is essentially think about it in the aspect of if it's in its starting state. So you have states where there's an operator, there's states where it's a number typing, there's states where it's an equals that's been pressed. That was the and then the fourth button is clear, but clear is actually going to do something different. It's not going to be its own state, and I'm going to explain kind of why, because you guys are going to have an aha moment on that one. But it looks at the right-hand side, and if you have a starting state, what math do you need to do in that starting state to take that right-hand side of 12.5 and move it to the left-hand side?
What?
And, okay.
Re-say that.
Yeah, I'll say it one more time. So if you have 12.5 in the right-hand side and nothing in the left-hand side and nothing in the operator, if your state is in the starting state, what are you going to do to make 12.5 become the left-hand side?
You could, like, equate it, right side,
What's the order going to be?
uh,
It's not right-hand side equals left-hand side. It's
left,
left-hand side equals right-hand side. What were you going to say?
something similar.
Something similar? Okay, good enough. So yeah, essentially you could look at it as a state where you have a starting state and you just say, okay, when something gets moved into the right-hand side, so as soon as I would hit, like after typing 12.5, I hit the addition operator, it's not going to put that addition operator in just yet. It says my current input is 12.5, and now I know that because the addition operator has been typed, 12.5 is not going to change. 12.5 can change up until you hit another button. Like if you type 1 plus 1, do you know that it's 2 just yet? No. You don't know it's 2 up until you hit another operator or until you hit an equals sign. Because up until you hit one of those, you could still type 2. You could still type 3, and then you would have 1 plus 123. Like, you don't know necessarily just yet that that right-hand side has been decided until the operator gets hit. Once that operator gets hit, you can say, okay, I know that it's in the starting state currently, so my operator is the starting state, and what it just returns is when you call that operator, it just says, okay, the right-hand side is now the left-hand side. And so it just automatically says, that's there. It just says, okay, because you hit plus, we now know that 12.5 is in the left-hand side, and we now know that the operator is plus. Now, what happens if you hit multiply?
The operator should change.
The operator changes. So you now know the operator is times. What happens if you hit the divide? It becomes divide. When does this... Oh, that's a question mark.
Here's the number one question. What happens if you press the decimal button? See, that, sir, is where you are wrong.
Oh, I should start the right-hand side.
Yep. And so that's where we go into another input, because now we know that divide is going to be concrete. So it's the same way in how Microsoft Paint is kind of stupid. As soon as I click out of that box, I can't edit. That's now part of the canvas. That's concrete. It's not going to change. And so that's why I waited to exit out of the box once we said something else. And so now that we hit the decimal point, you have 0 point. Because you know if you hit a decimal point, the 0 is going to be before it. And so now you're in the number typing. So what happens if you hit 2? 0.2. So when do we know when this is going to be, when this input is going to actually be able to be used on the right-hand side?
Equal to the right-hand side?
Wait, do that, because we can do math, though.
Okay, yeah, that works. Okay, so with this, like, when do we know that 0.25 is actually going to go to the right-hand side? When can we do the actual math? When is 0.25 concrete? When you hit equal. So if
or because there's another reason.
yeah,
There's another way it
what's
goes
the
up.
other instance where it huh? No, clear. You press another operator. And so if you hit another operator or you hit equals, then you know that 2.5 is now concrete. So you can move it over here into the right-hand side. And you have 12.5 divided by 0.25. Well, if we know that 12.5 isn't going to change, we know that divide isn't going to change, and we now know that 0.25 isn't going to change, then we know all of that math because we just hit the equals button. So what's going to happen now if we hit the equals button? It's going to form an operation.
But what specifically is going to happen to the left-hand side, operator, and right-hand side? Like what? Okay, so let's say we do this, right? So we got this. We press the equals button. It's magically done the math, right? Okay. What's in the operator?
Awesome.
No.
Yeah.
Doesn't it get cleared after you press equal?
No. Because remember, you can hit equal multiple times.
You're right. Okay.
Yep.
What's in right-hand side? No.
What?
So right-hand side has nothing.
Nope. Right-hand side stays. Yes.
I'm just gonna stop talking.
Yeah. So this is why I redid the calculator assignment so that I was like up to par with everything that I needed to know with like to answer these questions. So what's going to happen is now that you know that 12.5 divided by 0.25 is all concrete, you do the math for that. And so 12.5 divided by 0.25 is going to be the same as 12.5 times 4. This is me talking out loud so I can actually figure out the math. And huh? Oh, you already did it for me? Thank you. Okay, so then what you know is that you know that specifically, you know now the left-hand side is going to be, okay, I want to be able to clear this. Microsoft Paint, would you fucking work? Okay, this is stupid, so we're going to just take this, or grab a brush, and we're going to make it freaking massive. And we're going to just, that's why are you dumb? So, okay, I'm great at this. I love using Microsoft Paint, as you can obviously tell. Would you, anyone know how to just like be able to delete a specific?
Did you press backspace or delete?
Oh, I hit backspace. That's because Logan's computer is dumb. There we go. Yep, that works. Thank you. So now that we have this, we know that in here, specifically, we know that the left-hand side is now 50. So I'm typing in white, so we need to not do that. 5.0. So we know that that is now 50. So, do we know that this math is necessarily concrete yet?
No.
Do we know that 0.25 is going to change? 0.25 isn't going to change at this point. We know that divide isn't going to change and 50.0 isn't going to change. What is the display going to be currently showing? It's going to be showing 50. When do we know that we need to do this math again? When equals hit again. So if we do the math and if we hit equals again, then it's going to do 50 divided by 0.25, which means then what's going to happen is we're going to have this, and I'm not going to fuck up this time. Awesome. And then that'll be 200. So, what happens to possibly clear all of this? What are the possible situations of button presses that could clear all of this? You press clear. Okay, there's one more situation that could clear all of this information right here. Nope. Okay, raise your hands because I'm hearing like 4 answers. Mike. You type a new number. Because if you hit equals, it's going to be displaying 200. But if you start typing a new number, all of this math goes out the window. It essentially clears your entire calculator. Hint, remember that one. You're going to need it. Objective 3. I didn't say that. So basically, if you type a new number, let's say you type 2, what's going to happen is all of this is going to clear.
You realize you said that on a recording, right?
Yeah.
Okay.
I know I said all of this on a recording. It's a joke. I know that people will actually hear me. So basically, you now have the input of 2. You are basically essentially set back to your original state, but you called 2. So if we hop back into our IntelliJ, that was where I was talking about if there was a situation where you would need to look at essentially calling a function with something after changing the state. So if you were going and transitioning from equals to a number state, so if you were in the equal state and then you hit a number, what you know is the state is now a number state, but you would need to actually, like equals isn't going to necessarily handle that number, but you have a class that's number state, or whatever you're calling it, and you're going to essentially, you have a method call in there that will append whatever you need to display and do all your display stuff. And so after you switch it into that number state, you need to call that display with the number that was just put in. But what you need to remember is before you switch that state, you want to set it all back to 0. And this is where we talk about clear. Now, is clear an actual state? Who thinks clear is an actual state? Raise their hand. Who thinks clear isn't an actual state? Okay, so clear is not actually a state. You could make it a state, you could give it functions, but it's a little overkill if you do that. Because essentially what clear is doing is, think about how your calculator works, is if you hit clear, what happens to all the memory inside of it? Gets wiped. If you hit clear, is any of the previous operators you've typed still there? No. And so what you're doing in clear is you're taking all of your state variables, all of your states, and you're resetting them to your initial point. And so that would be like if we hop back into computer user, what we would know is that if we had a method in here called clear, what that would be like, what it would be doing essentially would be saying state equals new PC, because that was our initial state. Now if we had variables in there that were like the amount of time that it's been running, we would reset that to 0. We would say that anything that we created inside of computer user, that all of those variables would just be set back to their originally initialized states. That's why clear isn't an actual state. It's just a method call that just resets everything to the beginning. Yeah?
What's the difference like state and this state that is showing here?
So this first line, we're taking the variable of state and setting it equal to a new thing, right? This second line here, we're saying this state variable has a bunch of functions. I'm going to call one of the functions. So we're saying this instance of the state variable, this class that we're in, is going to call the function hello OS.
And yeah, specifically like saying state equals new PC versus saying this dot state equals new PC. In this case, on how we have all of this formatted, there's not really a difference. If we had a variable that was inside of the abstract class that was called state, and then we also had a variable inside of here that was called state, the difference would be of essentially this dot state and state should still be calling the same thing, but you want to be careful in that instance, because if you're extending an abstract class and that abstract class has the same variable name and you want to access that one, so if they have the same variable name, let's say if we hop back into our states, let's say that it has a name, like a variable name that's name equals operating system, like var name or val name equals operating system. String of OS.
What do you want?
Okay, I will type it. So,
Nice.
okay, so a string
Oh yeah.
of OS,
Got it.
and then if we were inside of
Yeah. Okay.
PC, and we also had a variable name that was val. No, you don't need an override. No, that we are not overriding.
Yeah, you're right. You're right.
We are doing val string or val name. Yeah, val name.
Val name string.
And that equals PC. Okay, this is giving us a red error.
Yeah, it's gonna say because it's the same.
Yeah, well, what I was trying to essentially explain is, I guess it doesn't allow you to do that. IntelliJ knows better. But like, if you do super dot name, it is going to pull that variable that is in the abstract class, the thing that is super to it. And this is the one that pulls the variable name that is currently inside of like that class. So like super.name is going to be OS. Versus like this, like if you had a variable, like maybe like, I don't know if we can put variables that are like inside of one of these functions, but if you had a variable name that was also called name in there, that would be this dot name. Like essentially keep your naming scheme separate and you won't have to worry about it, so that like state equals something and this dot state equals something are the same. As long as you don't just throw randomly similar variable names all over the place, you won't need to worry about that. Yeah.
So if you override, modify whatever the value is, and then change states, will the value of the super still be maintained?
Yes, if you're changing
Yeah.
the super value, yes, it'll be
And
the same. Yeah.
No, the question was if you override something that's in the current
if
one,
you-
will the super one change? The super one is extended and current, and so like if you have a specific like super.name, if you override it, like it will change for your class, but it won't change for anyone else's. So like if you say right now, if we say super.name, if that was var instead, and we just said super.name equals PC, that is not going to change it for all of the classes. It is only going to change it for this individual one.
Right.
Bas-
So that would just change it for this specific class.
Yeah.
Overriding it.
If you overrode it, right, then it would change for all of the classes.
So like, let's actually toss that into a function. So let's say that super.name is inside of hello OS. So if we put inside of this function super.name equals PC, that means only when that function is called, super.name will actually be PC. And it only gets changed after you call that function. Now, if you're calling that function in the initial, like if you switch operating systems to PC and then you call hello OS, then what will happen is it will be changed forever. But if you never call that hello OS method, super.name for this instance of PC will still be the string of OS. So this is where like you want to keep track of your variable names and make sure that if you initialize something on a super level, or you have something that you're changing around inside of a method, you want to make sure that it changes around for everything that it needs to access. Everyone kind of following on that? Sort of. How can I explain that better? Like what are we... Well, not how can I need to figure out how to explain it better, but where are we kind of glazing over on?
Does this even matter if we're making sure that we're naming things differently?
Well, specifically talking about saying super.name equals PC inside of hello OS, that is a thing you are going to need to keep track of for the aspect of if when PC is initialized, you say super.name equals PC, that is going to be different than saying super.name equals PC inside of hello OS. Because if you don't call hello OS, it is going to stay as the string OS. But if you say super.name equals PC outside of all of those methods, so that when PC is initialized, super.name becomes PC, then you know whenever PC is initialized, it is automatically changed to PC. That's the thing, that if you use that variable, you need to keep track that if there's a function that resets it, that function needs to be called, or you need to just have it outside of all those method calls so that when the class is initialized, everything gets reset. So if you had a number state and you were keeping track of the current number being typed, and you had that variable be set to 0 inside of a method, then you need to make sure that that method is called. If that method isn't called, then it never got set back to 0. But if you create it initialized, where if you say a new number state is always being created whenever you start typing, and whenever a new number state is typed, or whenever a new number state is initialized, you start that current typed value back at 0, then you should be fine. This is where it starts to come into play that when you deal with states, you need to think about your flow, you need to think about where variables are what, and what's going to be really helpful for figuring out what might be wrong is debugging. Because inside of debugging, you can see so much more than you could ever see with print statements. Because if you throw a breakpoint in somewhere for calculator, because you're running calculator and you know if you type this, then this, this, and this, then what happens is in this situation, it suddenly truncates and removes half of your information and you have no clue why. Like, you can't throw like a bunch of print statements in there to figure it out. But what you can do is you can throw a breakpoint in there and watch. You can watch the actual variable of calculator, open it up, look at its left-hand side, look at its right-hand side, look at the current value that it's displaying, and what you can see is what you can look at, and you can watch them change as you do step over or step into. You can watch as it runs every single method call to see while left-hand side and right-hand side change to make sure that everything is being moved properly. Like when we were showing in Paint, what we were showing was as things were moving, they should go from here, then here, and that's how it's running all of its method calls. And so that's where throwing a breakpoint in and watching and making sure it goes to where it needs to be. Like if you initially type 12.5, you can watch it go from your input and you can check to make sure that it goes into your right-hand side, and then you can check that it properly moves it over into your left-hand side. Like you can check all of this stuff to make sure that it does what you think it should be doing. And if it doesn't do what you think it should be doing, by doing step over or step into, you can see the specific line that's doing it. And if you know the specific line that's causing the problem, then either you'll be able to figure it out, or you can show us the line that's the problem in office hours and we can help try to figure it out with you. Because like if you just show us your code and you say, when I do this situation, suddenly my values do the math correctly, but then it truncates it and I have no clue why, your calculator could be completely different structured than mine. It could be completely different than Jesse's. It could be completely different than the person that's 2 feet over from you. Like, I don't know how you set up your code. I'm not going to be able to just look at it and tell why it's truncating. I may have an idea if it's a general flow thing, but I'm not going to know why you're losing information in this weird scenario because you're doing this weird janky stuff here. I'm not going to know. But if you tell me I'm losing information, here's the line where I lose that information, then I can go, great, I can look at that line, I can help try to figure it out. So are you guys kind of comfortable with the debugger? Yeah?
I hope so after the lab.
I would hope so too. And so you guys are comfortable with setting breakpoints, watching variables, watching them change, and trying to figure out where things are going wrong. That's going to be very, very helpful in this. Another helpful thing is make sure you're going in order of the objectives, because how you're going to be getting your points is you first want to do is look at the objective and write all the test cases you can possibly think of for that objective. Write your test cases first, then write your code. Because you don't want to write your test cases after writing your code, because you may think that it's supposed to do this thing, or you know your calculator does this thing, so you're writing a test because you think that's correct. Instead, read Jesse's documentation and go, okay, I need to have a test that makes sure that this happens. I need to have a test to make sure that this works. I need to have a test that makes sure that if I spam the decimal button, only the first decimal works. You have to do all those tests, and then what happens is while you code that method and those methods to do all of that, you can run your tests against your code and actually see where it might be going wrong, and then you can figure out while you're coding it what you might need to do differently. Everyone kind of hear that? Is it going to go in one ear out the other, and you're just going to work on your methods first and then write your tests? I mean, you guys aren't nodding, but I can feel you internally nodding like, who's this bitch telling me to fucking like write tests before I code? I want to write the method. Yeah, I know. I do too. I like to code that way. It is an awful habit. Try to break yourself of it, because it's good practice to write your tests first and then your code. If you write your tests based on what your code does, that's called what is it? It's like
Code-driven tests.
Code-driven testing or something.
Yeah, it's
like
code-driven testing, not objective-driven testing.
Yeah.
Which is what you should be doing.
So essentially, if you write the test based on what your code does, well, then you don't actually know what your code does wrong. But if you write a bunch of tests first, then you're not thinking about how you implemented your code, because you haven't implemented your code yet, and then you'll know if you fail one of your tests that you wrote correct tests for, then you know that your code is wrong, and you can fix it based on from those tests and debugging and all of that stuff. Awesome.
All right, let's go back to this.
Yeah.
Let's finish implementing everything.
Awesome. I gave you enough time to talk? Or while I was talking, I gave you enough time to write the methods?
I didn't write everything. The point was to show them. While
Yeah. Okay, so let's do the method call. Yeah,
Like I
questions.
wrote some.
Before we start that, I just have a question. And can you go to computer user
Yeah.
real quick? So are you supposed to extend that?
No.
No.
So computer user does not get extended.
So
It just
that-
happens to be that we're using the same methods, like the same name.
Okay, so that's why you basically use it as like the
Yeah.
Yeah. If
thing.
so,
You don't have to extend anything.
that doesn't work. That's unfortunate. So if you look here, there's extra stuff in here. So there's current processes, there's name, there's hello OS, right? So
Yeah.
all that stuff isn't done in here. Just we're using a lot of the same method names. That's all it is.
Yeah.
Okay.
Yeah, I saw a question over here. Yeah.
Are you gonna upload this code?
Yes,
Yeah.
I'll upload the zip file to Piazza. No, to the folder that all the review slides are in,
Yeah, so on the link to the website, there's a link to our review slides.
and I'll just put it in there.
So that's our nice little folder that will have all the helpful resources for you guys.
All right, so let's finish this up, right?
Yeah.
Okay. So in PC, we still have a couple things we need to implement. So I wrote the to Mac while you guys were talking. It's the same as to Linux, just I replaced the word Linux for Mac. What are we gonna do here for to PC? What am I putting here? Right. What?
User.state equals new PC.
If we're in a PC partition,
Oh, we're already in.
We're already in a PC, so this is the PC class. So all you're gonna do is that. Literally nothing's gonna
nothing. You don't need to do
Nothing's
anything.
gonna
There's no
change.
transition that needs to happen. You're already in there. You want to, because if you click to new PC, if you were in your PC partition and you said, I want to be in my PC partition, are you going to keep the information that you still have, or are you going to suddenly wipe everything? You're going to keep everything. But if you did this user.state equals new PC, you're going to lose all the information that you were just keeping. So you don't want to do any transition there.
Okay, so I want to go through these really quickly because I have another thing I want to bring up on this. So 2PC is going to be like that. Open text editor is just going to basically be the same as open browser, except it's going to return Microsoft Word instead. So if you guys notice, I'm adding this dot current process plus equals 1. So when the user calls current process in computer user, it's basically going to return how many programs are open right now. So like browser's a program, Microsoft Word's a program, and however many instances are open. So this current process starts at 0 when you start the computer. Every time you open a browser or open a text editor, it adds 1 to that total. Okay? So now that I've said that, what am I putting in here?
This current processes.
Yeah. Yeah, exactly. That's all it is. So, so this is, just for the sake of time, this is what your PC class is going to look like, your Mac class is going to look like, your Linux class is going to look like. They're all going to look the same. The only difference is in your Mac class, this will be empty, and the PC class won't be. In the Linux class, the Linux will be empty, and the Mac and the PC one won't be. Do we all get that? Do I have to go through each of the classes?
Do those transitions kind of start making a little bit more sense than where Jesse had just, like, Dr. Banner was the overall, like, computer user, and then you had Bruce Banner transitioning to the Hulk? Like, does it make a little bit more sense kind of how these transitions are working and when you're not going to necessarily implement them? Yeah? Is this helpful so far?
Very.
Yeah, okay. And so...
Sorry, I'm just really annoyed with the red line.
Yeah, that's fine. And so essentially this is where, like, how this structure is this is just basically reiterating off of how Jesse had his state slides set up, and at the same point this is going to be very similar to how you can set up your calculator. You don't need to set up your calculator this way. When people have asked me, is this implementation of my calculator the right way? My answer has been the same. You could give 4 competent programmers this homework assignment, and you're going to see 4 very different things.
Jesse gave 400 competent programmers this assignment and saw 400 different ways.
Yeah.
I know that because out of our people,
Oh,
we
that
get
was-
like 8 different
That
ways.
was
of
last
this.
semester. Saying 400 competent programmers
That's a
is
good
a little
point.
high.
That's a good point. Regardless, in our group of 15 people that
Yeah.
all worked in the same general area after we showed each other our code, everyone's was different.
Yeah.
Every single person's code was different. Mine was the ugliest. I'll be straight up with that.
Yours are Steven's, definitely. Steven, one of the other TAs, like him and Logan, like they're whenever they're coding something for the first time, their variable names are something.
That's an actual variable that Steven has used.
Why God has also been one of my
I
top.
usually go for like an XXXY3 or something like that.
Yeah, both of their variable naming schemes are helps makes it easier on our lives to try to figure out what's wrong with your code.
Okay, so I want to go over one other thing with
Yeah.
the states, right? So Jacob was talking about before how we might want to pass data through between states, right? So I want to let's go back to this whole PC idea, right? So you have a different PC on each one. You want to have the same users across board, right? So like if I have a guest account and like a Logan account and like a work account, right? So I want to have all 3 of those across the board whenever I switch to Mac or PC or Linux, right? Does that make sense for everyone? Right? So I'm going to go implement that, and you guys are going to help me along here. Okay? So in computer user, I'm going to create a new variable called users, which is going to be a list of strings. And I'm going to initialize it here as guest Logan in quotes and Jacob because we share a computer now.
Okay.
So I've got this list of users. So how am I going to bring it into each one of the states? Anyone have an idea? Okay. So here I'm going to go comma users. Okay?
So what is he saying that we are possibly now doing with the data? What's the term for when you create a parameter for a class? What's a constructor?
Right?
So he's
Yeah.
adding a constructor. So
I'm
like
adding
we
a constructor into the class. So here now in PC, I'm going to go here and I'm going to go users is a list of strings.
yeah, so I want to
string.
implement that in state and then also have it on the extend
No, I
state.
don't want to implement it. You'll see why.
Okay.
Yeah. And so the whole point here is that list of users is just going to kind of exist, right? But whenever we switch states, right? So when we switch to Linux, I'm going to pass users through. So here, I'm also going to go, comma, users is a list of strings, right? So that means that regardless of what state I'm in, it has users, right? It has the same list of users. Do we all get that? Cool. So let's say here, sorry, let's say here I went and did users dot remove users equals list of, I don't know, Steven, right? So let's say I change this value of users here. Where's that going to change the value?
Only in your computer user class, right?
Right, yeah. But what if I do this dot state dot users? Sorry, that doesn't work. That was the point. I'm sorry. So there is no this dot state dot users class variable. There's no this dot state dot users variable. So you can't change in any of the states. The only way you could change it is if you were to go here and go state equals new PC, bringing in this and users, right? So that's the only way you can change what users are there. Does that make sense?
So you're creating another like users in the function, like another one, users, and then you're adding Steven, and then you
No, so I'm replacing all of them with just Steven, which is why it's creating a new one, right? So when you have a computer, you generally don't want to change what user accounts are in the middle of like working on the computer. So you shut it down, you change the users, you turn it back on.
Wouldn't the users, because it's a non-primitive data type, have a pointer? And so,
You're thinking in C, man. You're going.
no, but like users is stored on the heap. When you pass in users to new PC as a constructor, that users is not going to be a copy of users. It is going to still point to where users is.
Oh, yeah,
and by
yeah,
reassigning users equals list of Steven, users now points to list of Steven,
Yes.
which means it would change live. Because the PC of users variable still points to the same direction.
Yes. What he just said was correct.
Yeah, so
It's been a long day, everyone.
okay, so let's say that like,
let's try that again. Okay, so here, right, even if I didn't have this line, right, so if I come to this line of code out, what Jacob and I just totally didn't discuss was the fact that
on the mic, on
Yeah.
the stream,
was the fact that this instance of PC would change anyway, because users is a value that's on the heap, right? And so that value gets referenced from everywhere. So right here, when I create this new PC, this is a reference to users, which is a variable at 2345556. Random number, right? So this is still editing users at 2345556, right? So since this is editing the same thing, it's going to edit it within everywhere that calls that variable. Does that make sense to everyone? Right? Kinda? Yes? No?
So it's stored in a heap, like
Yes,
Yeah.
because it's stored in the heap, it's being pointed to.
okay.
Mhm.
So it's creating a copy of the list.
it's not creating a copy. What it's saying is that essentially when you pass into new PC users, that's passing in that address. Now, users has its own variable name that's called users, but it still points towards that same spot on the heap. And so even if that heap changes, the variable of that actually may okay, I'm not completely sure, because essentially what we'd be looking at is saying that if we're saying currently the list that is like a guest, Logan and Jacob, is at like 1, 2, 3, and then we say list of Steven is at 4, 5, 6. We're saying this users is going to point here, but then what we do is we later say that this users now points here, but the memory address of 123 was the one that was passed into PC, and so you were right on your initial statement.
Once in a while.
Yeah. Essentially, like, if we were to name them something different, so if PC instead took, like, user list, that essentially what happened was users was the initial created, and we said users is at 123, and it's guest, Logan, and Jacob. What happened was we passed it into new PC as a constructor. That constructor had a variable name that was then initialized as pointing to this direction of this memory address right here.
So when that's initialized, it doesn't change within the class.
Yeah. And so even though outside of that class, users now point somewhere different, that means users now has a value of 456, but the users that's inside of PC
is still pointing to 1, 2, 3.
Yeah.
Does everyone understand that after we figured that out? Okay.
Yeah,
I knew there was a reason I did it that way.
Yeah. It's a little confusing on that one, but that one, like, you shouldn't need to specifically remember, like, because any passage of the only data input you're dealing with in calculator is what the number is that's an integer, and that integer is a primitive data type, which means it's stored in the stack. So you don't need to worry about, oh, what's pointing where when you're passing it through, because you're going to be passing through an integer that's between 0 and 9.
So yeah, we can go back here and let's say users is an int, right? And it's just how many users there are. Okay. So if I back up here and I just say it's equal to 3, right? So users, sorry, this is now going to yell at me. It's my favorite. So users here, if I now say, if I switch users equal to 4 here, then it will change.
It won't.
No, it still won't. Yeah.
So essentially what it is that new PC...
Tonight's being a thing.
Yeah. So new PC, if it's initialized with this comma users, that means the new PC class has its own parameter that is holding 3. It's just holding 3. There's a copy of that 3 that's been made. It's not pointing anywhere. It just says it has its own variable that's name users, and it has a value of 3. Then what happens if we say that the users that's in computer users is now equal to 4, that just means that in the computer users stack, it has a name of users and a value of 4. But still there's a stack that exists that's PC's stack, that has its own users that points to 3. But that hasn't been changed just because they share the same variable name. That was one of the confusing things that essentially Jesse was showing about in his stack and heaps question. Where, what points, and that type of thing. And so essentially, like, you cannot, like, the users is not going to change for the PC until you fully reinitialize it, like you see in line 17, with that new parameter.
Now, the reason I did this, okay, the reason I did it this way and did not put a variable here, so now if I went var users, is an int, I knew there was a reason. I did this for a purpose. Right, if I went here, right, and then I took this out, this is the other way you could pass information, right? So you can go here, and then you can go state dot users after we do a couple things here. So we take away users here.
Yeah.
So we have users here, right? So users is still the same value. This is just being pissy about something else. So users here would be the same value as the users that's in our state here, which is the same value as here when we made it, right? So that way you'd have an overarching one, so that way regardless of when you change states, it would always be that one, okay?
So I know we're saying a lot of extra stuff that's covering on states, how to keep track of variable names. What we're trying to talk about is there are a few things that where Jesse showed in his slides, some confusing scenarios where variables were named the same, where they're stored, like what has access to what, when you need to remember to pass things through. Some of these things, some of you are going to hear and it's going to glaze over your eyes and you're not going to necessarily understand. You don't need to understand all of this. Like, the only reason why, like, as you can see, like, Logan's tired and, like, there's a few mistakes that are being made. Like,
A few.
we are still working on understanding all of this ourselves and, like, really trying to figure out and master this entire thing. What happens is you'll just start learning more and it'll just tack on to your knowledge and you'll understand more. You don't need to necessarily understand every single thing that we've said today. The point on why we're saying these other things is some of you do understand partially what we're saying when we're explaining some of the other state stuff. But if we don't mention these variable names, if you name something the same thing and you try to do something fancy, what may happen is you may not know that full repercussions of doing something fancy, which if you pass something in and you have a similar variable name and it points to the same direction, like you worry about a bunch of other stuffs, what may happen is you may come into an error that we never talked about and we don't want that to happen. So like you don't need to understand everything we're saying because there may be a person in the room that does understand what we're saying with some of this stuff, and this is warning them to say, be careful when you do this thing because it may raise out this error. It may cause you to have a copy instead of actually updating what you want to update. Or it may be the opposite. You don't want to update something, but you're accidentally updating it because it's pointing towards that same direction. Okay. Shoot me with some questions right now.
Maybe this isn't the right question for right now, but the lecture question from Monday with the GUI stuff, I was wondering how might you go about testing that, or haven't gotten to that yet?
Dude, testing doesn't exist. so it's a weird place with testing.
Yeah.
Okay, so last semester we had like what 4 days on GUI or something like that, and he had lecture questions every day, but they were optional because you can't really test GUIs in the autograder. The best way to test it is to launch a GUI and press the button and hope it does what you want it to.
I was looking for stuff on like scale documentation.
Yeah,
but, you know, like you can't even simulate a mouse click.
Exactly. Testing doesn't really exist for GUIs.
Okay.
That's where, like, essentially, that's why in Calculator, all of the actions are buttons because you can simulate button presses, which is also why Jesse gives you guys the full GUI. Because by giving you guys the full GUI, we know that there is no error with that. All you need to do is you need to implement inside of the handle method, because how he's going to simulate button presses, which you can do, is you can simulate button presses by calling that action that is supposed to be called when the button is pressed, and you call .handle of null. And so that's where essentially, like, we're trying, like, that's where Calculator is done a little bit for you, because if we didn't do that, it would be almost impossible to grade. Like, we wouldn't be able to test if you had a functioning GUI for that. And so a lot of what I can say also as a pointer, a few things that I've seen on that have popped up on Piazza during my office hours that I got like the email notifications about is like with your imports and GUIs and Java effects and Scala effects, be very careful. If you are importing something, make sure you import the right thing. I just helped someone today where they were importing Java effects for the event handler, but for the lecture question, they were importing Scala effects for the mouse event. And so what was happening is they couldn't even see if their code was properly compiling, because when you have an event handler that's Java effects and it carries a parameter that is a mouse event, but that mouse event is imported from Scala effects, those two don't work together. You had, like, I had to switch his imports and just show him that, like, if you, like, you had to look at the slides real closely. It was slide 22 was specifically about, like, had the imports shown in it from the lecture question, that what you needed to be careful about was for the event handler and the event itself of the mouse click, that was a Java effects import. But then when you deal with other GUI stuff and creating buttons, that is going to be a Scala effects. And so you need to be really careful with your imports, or else what may happen is you're going to get a compile error and you're not even going to be able to run your code, so that if there is a GUI, you're not even going to be able to click on the button to see if it works. And so that's where you need to be really careful with your imports, because some of it, even though you are coding in Scala, it needs to be imported from the Java effects package. And if you're coding something in Scala, it may need to be imported from the Scala effects package. And it's kind of confusing, and the best thing that I can say is, if you don't know which one you need to import, look at the lecture slides and try to find examples where Jesse did something similar and figure out what you needed to import. You also have the entirety of actions.scala inside of Calculator. Those have imports in there as well for Java effects and Scala effects. And so double check in all of those ones as references for when you have later lecture questions on GUIs or later things that you need to do on imports. And worst case scenario, if you can't figure it out and you're crunched for time, just try different imports and see what you get until it compiles. Like, you can just swap them around and keep doing Alt-Enter and having IntelliJ say, these are the packages that you could possibly try. Just try them all if you need to try to figure out what actually will compile. So that was like a little bit of a pointer for, like, be careful with your imports, because that was the thing that I've seen a few things on. Another thing is Java effects gets really picky with which JDK you're in. There was one person who came to my office hours who essentially didn't create an Oracle account and instead tried to find like a different version of the JDK 1.8. But what he found was like a slightly different implementation, and what had happened is it didn't have Java effects support because he didn't want to create an Oracle account. Like, I was able, like, he really didn't want to, and I was able to, like, I run Linux as my primary boot and have for about 8 months now. I've been using it as a dual boot for a while, and I just completely decided I'm not even opening my Windows partition anymore. I had to look inside of my Windows partition that I haven't looked at for 6 months and looked in my downloads folder, and I was able to find, luckily, a file from February I had downloaded that was the JDK 1.8.exe for Windows, so I could send it to him so then he could actually install the proper JDK. And once he did, he was like, oh, it works. And I was like, yes. There you go, but like, just make sure you're on the proper JDK. If you cannot import Java effects at all, that means you're on the wrong JDK. If you are getting errors not with the imports, but rather with like type mismatch, and like it's saying, oh, your event handler is this and it doesn't accept this, that means you're like probably importing the wrong thing. So like keep all of that in mind and try to figure it out. Worst case scenario, try a bunch of them, or make a post on Piazza and hope that one of us can see it before the lecture question is due.